Over the course of this multi-part video series, we'll explore the technical and practical science of this exciting advancement in medical technology and distill that science into the simplest possible terms. It's our hope that when this series is over, you will find yourself armed with the tools necessary to pass your understanding on to your clients, thus easing their anxieties and greatly increasing their chances for successful direct neurofeedback sessions. As you can see, our courses are broken into 5 modules that align directly to the course materials you have been assigned. You may want to keep those materials handy during these videos, as the content may come to life as we explore these concepts together. In Module 1, where we will begin today, we will establish a foundational understanding of neurofeedback as a whole, its origins, its history, its science, and how its science can be explained to the average client. So let's begin by examining how direct neurofeedback evolved from the origins of neurofeedback itself, specifically what we call traditional neurofeedback. To better understand traditional neurofeedback, consider a mirror. Every day that mirror helps you use your body to perform tasks that you can't see with your naked eye. You comb your hair, shave your face, put on makeup, tie your necktie, all without being able to directly observe your own face. Most likely, you rely on the feedback from that mirror to teach your brain to communicate to your hands to know the proper steps. Chances are, after you've performed these tasks a few times, your brain will have processed enough positive and negative feedback that it likely will be able to recreate the proper actions and adjustments without using the mirror at all. My brain has seen my hands, my neck, and my neckties enough times that it no longer needs this feedback to recreate success. My brain once felt reliant upon the mirror. Now it has learned a new way by gathering positive feedback on how to tie a tie and negative feedback on how not to tie a tie. We call the brain's ability to teach itself new ways to function neuroplasticity, and it is one of the core achievements that all forms of neurofeedback seek to deliver. Now imagine if we had a mirror that allowed our brain to see itself function, to watch brainwaves functions, like the fingers on a hand, and to use that visibility to train those fingers to perform the tasks that we want to perform. We call the process of gathering feedback on our brain's activity and using that feedback to take control of our brain's activity neurofeedback, specifically traditional neurofeedback. Clearly, our goal is to understand the science of neurofeedback, but before we can talk science, we first need to make sure we've studied our history. In the early 1960s, Dr. Joseph Kamaya became the first researcher to prove that human beings could will their brains to behave a certain way if a simple reward system was established. By being rewarded for making particular adjustments, the likelihood of those specific adjustments to occur grows greater. This is called operant conditioning. Bolstered by this research, Dr. Barry Sterman began experiments of his own with cats. His cats had their brain waves monitored, and when Dr. Sterman observed what he called the goal brainwave, he gave the cats a treat. After a short period of time, the cats recognized that a certain brainwave was yielding rewards, and suddenly the cats, or operants, became conditioned to produce the goal brainwave quite adeptly. For Dr. Sterman, that particular research project ended with that finding, and a new project soon began. This next project was to study the toxicity of exposure to rocket fuel, the kind used to fuel NASA's Luna lander. For this project, Dr. Sterman again experimented on cats, injecting them with concentrated doses of the fuel. Not surprisingly, it made the cats sick. They began having seizures. Even less surprisingly, the more fuel he gave the cats, the more severe the seizures. What was surprising was that some of the cats had no seizures at all. That's when Dr. Sterman realized something important. The cats that weren't having seizures were the ones left over from his previous experiments. Neurofeedback had not only helped them earn more treats, it had strengthened their brains and elevated their seizure threshold. Thus, the concept of neurofeedback gained its first measure of notoriety. Today, neurofeedback has come a long way from its cat-abusing roots, but the chief tool remains the same. This is an EEG, and that's short for electroencephalogram. Since electroencephalogram doesn't exactly roll off the tongue, let's just call this an EEG for the remainder of the course. This EEG will monitor my brain's electrical activity by measuring the electrical waves that it creates. You may already know those waves by their official name, brainwaves. Brainwaves are, essentially, your brain's distinct electrical patterns. And just like we use the mirror to train our brain to guide our fingers, we can use the output of an EEG to train our brain to guide itself. We can use this feedback in one of two ways. The first way we can use the EEG's visibility is to try to consciously move the needle of the output to move our brain waves toward a so-called goal wave, much like Dr. Sturman's cats did. The client receives feedback on their current brainwave and can trigger pleasant tones in the machine when they reach the goal wave. We call this method of neurofeedback and retraining of our brain traditional neurofeedback. Traditional neurofeedback is a session in which the client plays an active role in the session. As the client produces certain types of brainwaves, he or she receives positive reinforcement. That makes the client's brain more likely to continue to produce those brainwaves. This encourages them toward the type of activity they should be creating. Much in the same way that a mirror will show you that your partially tied tie doesn't yet look like it should when fully tied. Over the course of 30 to 60 sessions, the client's brain gradually learns to perform the function by itself, and thus the feedback is no longer needed. The other type of feedback is known as direct neurofeedback. With direct neurofeedback, the client doesn't use the readout of the EEG to try to manipulate their brainwaves by themselves. Direct neurofeedback does not try to train the brain at all. Instead, an ultra-low power neurostimulation is used to disrupt the brain's frozen, stuck patterns. This causes the brain to reboot those patterns, much like a frozen computer. That reboot allows the brain a chance to run its built-in programming and re-optimize itself, much like your computer after it's been rebooted. That's direct neurofeedback. So let's recap. Traditional neurofeedback is the mirror method. The client conditions themselves based upon pleasant tones or other reward systems to learn to create a goal brainwave. Sessions last about 1 hour, and clients can start to observe results in 5 to 15 sessions. Clients play an active role in their own session, and successful results can be observed over a span of anywhere from 30 to 60 total sessions. With direct neurofeedback, on the other hand, the brain receives an opportunity to optimize its own activity. The sessions only take 30 minutes or so and yield very fast results, often in the first 3 sessions and usually in the first. The client plays a passive role in the session as the low power stimulation from the EEG does the work for them. The client doesn't have to train or untrain their own brains. The signal triggers a reboot, and the brain leverages its natural neuroplasticity to begin to create and recreate positive brainwave activity. Sessions usually reach their successful conclusion in 25 sessions or less. In our next video, we'll take a look at some helpful ways to explain these concepts to your clients.